In this project, we're going to create some script files. Again, this is just one chapter and one section on scripting, so you're not going to become an expert at it, but at least you see what basic scripting is going to entail. First, we'll use the Vim editor and create a script file called diskconfig.sh. It's good to put the period sh to help visually identify that this is a script file. We'll enter several commands. I'll start the file with a shebang, the !! and path of the shell interpreter, followed with a comment that describes what the script is going to be doing. The next lines that I've entered, I'm creating a variable. I'm going to execute a command called hostname to pull the computer name and domain name and store it into the variable. And then I'm going to echo to the screen to let the user know what the report is saved as. Notice the host name is surrounded in backward tick marks. That is to the left of the 1 key on most keyboards, not the single quotation marks found by the enter key. So be careful. Here I will show typing hostname is a Linux command, and it pulls the computer name and domain name of the system the script is running on. I'll add some more commands now. The next set of commands is going to echo a title into the filename.report. The /n are carriage returns or blank lines. And then I'm going to run the command lvscan and report any information using the double greater thans to append the output of lvscan into the file name. The next lines that I've entered will echo another title, followed with some carriage returns to help separate it out from the previous command. It will then run fdisk and view the file system. It will view the first 17 lines with the head command, and the output will be appended to the file name, again with the double greater thans so we don't overwrite the previous contents of the report file. The last two commands are going to, again, print a heading, followed with some carriage returns. And then we're going to run the df command, pipe it to grep, and we're going to eliminate the temporary file systems, basically the file systems that are stored in RAM. We want to avoid viewing them and see the actual file systems that are on storage media. So that's why I use the -v. I bring the man page of grep up in the right terminal here, and we see where the lowercase v inverts the search. So instead of viewing what you're searching for, it hides the term that you're searching for and shows everything else. Now it's time to save. With the :wq. Once the file is saved, if we look at the permissions, we'll note that there's not an execute write. So we'll issue the chmod. I want the owner of the file to be able to continue editing the file, but also have execute rights. Anybody else on the system, read only. I don't want them to be able to make changes. Let's view the file again. It shows up green in color, and now we see the X for execute. Let's see if we have any mistakes. /diskconfig.sh. Disk report saved to localhost.localdomain.report. If you received an error, see if the error said what line number inside the script file the problem was found. Use the Vim editor to reopen the file and check around those line numbers for typos, missing quotation marks, that you may have had. Let's view the file, the report, by using the less command. Here we can see what the carriage returns did, the /ends. They provided returns. I have no LVM configuration on my system. Partition configuration is listed. And at the end, the df command showing all of the physical partitions. Your system will likely have more as you have completed steps in Chapter 5. I will use Q to quit. So that is a basic script report. That way we don't have to remember how to issue all those commands, especially if we need to issue this on several servers and build a report. We will now create a script that can be used to back up a directory. We'll use vim and create a new script file called dir backup.sh. We'll again insert a shebang and a comment. After the first few lines are entered, we'll next need to check for the usage and make sure that the user has entered the script file name followed by a directory to back up. This test is done with an if statement. An if statement is good to check for a single value. So we're testing $pound. This is found in your book on page 387. It's checking to see if anything was entered after the name of the script. If it's not equal to at least 1, meaning that you've typed a directory path, then the if statement fails. So we have then, and what happens if we failed to insert a directory path to back up. We're going to echo a help message to the screen and say usage is the $0 prints out the first thing that was typed, which would be the shell script itself, dir backup.sh, followed by more text, directory to backup. This will be a cue to the person using the script that they must type the name of the script, followed by the path to back up. We'll then move to line 7 and exit with the failure code. So the script will terminate at this point. Now, if the person was to execute the script correctly, we need to enter the code to continue backing up the directory. I've entered the code, echo to the screen. If the if statement passed on line 4, it will jump to line 10, performing backup. It will wait 3 seconds so the user can see that the script is going to operate correctly. It will run a tar command, which we talked about in Chapter 11, and it'll create a compressed file of the directory supplied. Once the tar command completes, the screen will display the backup is completed, so the user knows the script has finished. As before, we need to save the script and fix the permissions. Now we can test the script's operation. I'm going to first fail by just executing the script without typing a directory to back up. Now we see that first if statement determined we did not type anything, and our echo to the screen. Usage is our command we typed, and it tells us we need to supply a directory. Let's reissue the command, but this time put in a directory that exists. Pressing enter, it passes the if check and goes to the last part of the script file, performing backup, runs the tar command, and now backup is completed successfully. ls-l shows us our backup file and our two script files. You want to take a screenshot at this point. Now we will improve our backup.sh or change, depending on how you want to think about it. I use the Vim editor and edit the dir backup file again. This time I'm going to remove the top if statement. I'll use my dd to delete the lines. I'll then insert the following new information. Lines 4 and 5 that I just entered will echo a question or a prompt to the user. The /c avoids a carriage return, so the prompt is blinking at the end of this question. The command read will execute, and it will store anything entered from the keyboard into a variable called ans. We now need to modify line 9. Instead of $1 this time, meaning reading information placed outside or beside the script file name, we'll change this to ans. So this script will run without any inputs. It will then ask the question, store the information in an ans, and then run that here on line 9 to back up the folder. We'll go ahead and quit. When we run the command this time, we don't need to supply any information because it will ask us. This time, let's supply a new directory, etc pki. As before, it will perform a backup, copy all of the files, and then exit with backup complete at the bottom. Let's improve our file further. Use the Vim editor to edit the dir backup. We have a problem. Every file or directory that we back up is stored into the same file name, backupfile.tar.gz. Let's modify that so that we can store the name of the directory and the date that we ran the backup. So let's edit our script. Let's add some new lines after sleep on line 8 on my screen. We'll add 2 more lines. The 2 lines I just entered is going to store in a new variable called file name what somebody typed in as the answer, and it's going to pipe that into the sed command and replace any / with dashes. Because when we create a file name, we can't have any / in the file name. But when it asks the question on what do you want to back up, you have to specify like / etc / pki. So the 2 / in that would be removed and replaced with the dash. Next, we're going to record the date and store that into a field. I pulled up the man page for the date command, showing you that the %f, what does it do? It displays the full date. So year, month, and day. Now, I need to modify line 11 so that it can include the variable information file and date. Notice I can use date as a variable name because it's uppercase, and Linux is case sensitive, so it does not conflict with the actual date command in lowercase. Again, be careful on line 9 and 10, as those are backward tick marks, because this is a shell script running actual Linux commands. So single quotation marks would read it as ASCII text and not actually run the commands properly. So line 11, instead of backup, file, we're going to replace file with the dash, the $sign, the variable name, another dash, and the date variable. We'll also modify line 13 to include the same information. Watch case sensitivity, please. Okay, let's save the file and run it again. It asks us the question. Let's again back up the PKI folder. At this point, it says take another screenshot. You'll notice at the bottom of the screen, we have backup, and we have etc PKI, and it looks like it avoided the date. So I have noticed I've got an error. Something with the date is not correct. I'm also noticing I have 2 dashes with the file name. So I'm going to take one of the dashes out and try to fix this a little bit better from what it shows in the lab. Let's use Vim again before we finish our screenshot. So I'll take out one of the dashes. And I notice my man page here on the right shows %F and not $F. Now with those fixed, I will save the script and try again. Very common to have flaws in your shell script. One simple character, a $sign to a $sign, can make the script not function properly. Now with the fixes, I see that the backup file will show etc PKI, meaning the folders that I specified to backup, and then the date. I'll do a long listing. And now we have 3 backup files. So originally, everything was just being overwritten to backupfile.tar.gz. But now that we've expanded our script, we'll include the directory name and date. So if we back up tomorrow, it'll be a new file name for the PKI. It'll be 10.1 for October 1st. And this is a long lab. Let's move on and create another script file. We'll call this one Family Database. This one you will enter a large script. As you're typing in your script, you'll notice on line 5, the echo command is going to echo several lines. So notice the double quotation marks does not end until line 8 after the \C. You'll also notice that we have a loop that we're creating. So while a condition is true, we're going to keep asking this question. These next lines I've entered is going to read from the keyboard. So after the echo is displayed, the user will make a selection, A, S, or Q. That'll be stored in answer. Then we'll use a case. Since this is more than one thing, like an if statement can test for one thing, but here we have three things to test for, A, S, or Q. We'll run that into a case, sometimes known as a switch case function. So we're going to check, what did the user enter? And we can look for a lowercase or an uppercase a. At this point, I entered all the code that needs to be run if the user enters a lowercase or an uppercase a. I asked 3 questions with the echo command. I used 3 read statements to pause and wait for the user to input data. At the end, I take the information in the variables name, relation, and phone, and I separate them with a tab. Here on line 17, the \t is what is used to separate these with a tab. It will then store into database the double semicolons end this case, and then it will loop back and ask the question A, S, or Q again. What if they entered an S? Now we enter that information. Here I've entered what somebody would be asked if they press S or capital S. What word would you like to look for? It'll read from the keyboard. It will then run the grep command on what they typed and look into the database file. It will then sleep for 4 seconds so the user can read the contents on the screen. At that point, the double semicolon will cause the loop to run again and ask the question at the top on line 5, what would you like to do? Now we need to enter the choice if they hit Q to quit the program. Now enter the 2 lines. If they use Q or uppercase Q, it will issue the command exit, and then the script will be done. What if they enter something that is not the letter A, S, or Q? Here I've recorded down the last few lines of the script. If if any other letter is entered, we represent that with the asterisk. We're going to echo a message to the screen. They must enter A or S, and then sleep 4. The book, I would think, needs to update this to add, you must either enter A, S, or Q. We then end the case by spelling case backwards on line 29. And then done, we end the loop on line 30. Let's save the script and see if we found any typos. We'll fix the permissions. And then we can run the script. We'll use A to add an entry. Here I see I made a typo with the. After an entry is entered, we'll use Q to quit. Now, I want to edit that file and fix my typo I've seen. The file is saved. If you want to, you could enter a few more users. In my case, I want to rerun the file and check to see what if I enter a wrong value, such as B. Here I get my warning message. 4 seconds later, it reloads the question. I can use Q to quit. It's not part of the lab, but go ahead and look at the database file. Now you can see the information that you've entered, and they are tab separated. Next, we will move on and talk about Git. It is a versioning control for scripts. If you'll remember our dir backup script we created, we modified it a few times. So Git helps us to have point-in-time restores if we make some code changes and then want to revert back. For Git to work, we must install that on the system. From your shell, use the dnf command followed by the keyword install, followed by the app or application we want to install. In this case, git core, and press enter. It will have to check the internet, and then it will display, do we want to install this application or not? Answer Y and press enter. Some applications require several other tools to be installed for them to function. In this case, it only installed one tool. Depending on your install, it may ask you to install multiple packages. Now let's make a directory. After the directory is made, let's move our shell scripts that we've created. Now I'll change into the directory. I'll do an ls just to make sure they are located there. I'll initialize the Git. So we've initialized the versioning control. The files that it has found has now marked those as the beginning or master files. Let's do ls-la and see if anything was created inside this folder. And we see we have .git. And this is how it's going to have a subfolder here and keep track of changes. Check the status. So right now we have some untracked files. We want to track these files for changes. Let's add them all. Recheck the status. Now they are being tracked. The lab wants us to try to commit the changes. We will get an error. The name and email address were not configured. To avoid getting the error again, configure the email address for anybody anytime that you want to commit. In a real situation, you'd use your real email address. Let's reissue a similar command and specify the global user. Again, typically you'd be doing this as a non-root user and specify your actual username. Reissue the commit again. Now we don't get error messages. But since no changes, it says nothing was there to commit. Now let's make a change to one of the script files. In this case, disk config. We will add 2 lines to the bottom of the screen. Remember, you can use the O to open a new line at the bottom when your cursor is on the last line. Here I've entered the 2 lines. I'll let the blank line on line 15. I'll save the changes. Check the get status. Here we're alerted that a file has been changed since the last commit. Let's re-add all the files. Let's recommit, but this time on the commit, let's add a title or tag on what changes we've made. This will help in future if we need to roll back. We'll have meaningful information on what we did at the different commits. Looking at the log, here we can see all the changes that we made through our history of editing our script files. On step 25, they want us to reset to the first comment, and we need to get the commit number for the first comment. So this section here. Since I'm working in a graphical interface, I could simply highlight and use my center scroll wheel to paste. However, if you're working at a terminal screen, you may not have the copy-paste functionality. So if I rerun the git log, I can search for the first few letters. That way it'll pull out just that one line. Except now I need to get rid of commit. So I can pipe this to awk. I use awk to print the second column, since the ID number that I'm needing is the second column. Commit would be the first column. I'm going to store this into a variable. I'll verify that the correct commit number is stored into my var1. Now I can easily use it in the command. Had a phone interruption there, but I'll use git reset, and I'm going to hard reset to the commit ID for our first commit using the $myvar1. Now let's check the disk config. We'll notice that the lines that we entered no longer exist. So we're able to go back in time. I'll run through the rest of the commands. Don't forget the last screenshot.